First, let's briefly talk about Python. What is it exactly, and what are its powers? Python is a programming language loved by many people due to the fact that it's easy and intuitive, it's free and open source, and it can be widely used for a variety of tasks in order to solve so many everyday problems. At the end of the course, we're going to talk a little about the details of Python. But first, let's install Python and get started. In this course, we're going to use Python 3, Python's newest version. If you're on a Linux computer, you'll most likely already have Python 3 installed by default. Open your terminal and type Python 3. If everything is installed correctly, you'll see a short message showing the Python version. In that case, you're ready to work with Python. Otherwise, go to the Python website and install Python for your operating system. The Python shell that starts when typing Python 3 can already be used in order to execute some basic Python commands. You can also create a Python file and open it in your code editor. Make sure that the file has the .py extension, so Python knows that it's a Python file. In order to execute the code within that file, write Python, followed by the name of the file and the py extension. Perfect! We just executed our simple script. In this course, I'll mainly be using the shell directly in order to explain the concepts. However, feel free to follow along using the editor instead. In Python, we can use literals in order to encode data and put them into your code. A literal is data which values are determined by the literal itself. For example, the number 200, the string hello, the string Python, or the number -89. Any other data, such as name, C, age, and print, are not literals. We don't know what value they have or what they're supposed to represent. There are 4 types of literals. The first literal type is the integer. An integer is a number that doesn't have a fraction. So for example, the numbers 200, 1,289,901, -90, or 1 million. The underscores in the 1 million are just a way for developers to make large numbers more readable, but they aren't necessary. There's also octal numbers. If an integer number has a 0 in front of it, we know that it's an octal number. You can calculate the value of an octal number by first assigning a value to each number from the right, starting at 0. These values are used in order to calculate 8 to the power of these values. It's 8 since it's an octal number. Then we calculate the results. 8 to the power of 2 results in 64. 8 to the power of 1 results in 8, and 8 to the power of 0 results in 1. Finally, we multiply the result of the previously calculated values with the numbers of the actual number. 64 times 1 is 64. 8 times 2 is 16. And 3 times 1 is 3. Then there's hexadecimal numbers that work almost identically to the octal numbers. However, instead of using 8 as the base, a hexadecimal number uses 16 as the base. You can identify hexadecimal values by the 0x in front of them. First, we calculate the position of each value starting from the right. These values are used in order to calculate 16 to the power of these values. Then we calculate the result. So 16 to the power of 2 results in 256, 16 to the power of 1 results in 16, and 16 to the power of 0 results in 1. Finally, we multiply the result of the previously calculated values with the numbers of the actual numbers. So 256 times 1 is 256, 16 times 2 is 32, and 3 times 1 is 3. This results in 291. Then there is another type of number, namely floating point numbers. A floating point number has a non-empty decimal fraction. Numbers that contain a lot of decimals can also be written with an e in order to represent the number in a more economical form. Then there are strings, which are used to represent text. In order for Python to recognize the value as a string, the value needs to be wrapped in either double quotes or single quotes. If you need quotes within the string itself, you can do so by using a single quote if you started the string with a double quote, and vice versa. Another way of being able to use quotes within a string is by using the escape character. The escape character lets Python know that the quote after the backslash doesn't mean that the string ends there, but it's just a quote. Lastly, there is booleans. There are two boolean values. Something is either true or something is false. Sometimes you'll see that the truthfulness of a value is represented by either a 0 or a 1. In this numeric context, a 1 means that the value is true, whereas 0 means that the value is false. Let's summarize everything that we've just learned about literals. First, we have several ways to display numbers in Python. An integer is a number without a fraction, and can also be displayed as an octal or a hexadecimal number. Then there is floating points, which are numbers that contain decimals. Strings are used in order to represent text, and can be wrapped in either double quotes or single quotes. If you want to use quotes within quotes, you can either use the other type of quote in order to make sure that Python doesn't see this as a delimiter and ends your string, or you can use the escape character to let Python know that the quote is a special character. Lastly, there are Boolean values that specify whether a value is either true or false. They can also be represented as numbers, 0 being false and 1 being true. Let's run our very first program. Let's see what happens when we run this line of code, print hello future Python programmer. After running this line of code, you see that Python returned a sentence saying hello future Python programmer, the exact same sentence that we saw on the line that we just wrote. Let's take a closer look at the print function that we just ran. The line that we previously wrote consists of the word print, an opening parentheses, double quotes, a line of text saying hello future Python programmer, double quotes again, and closing parentheses. Combining all these characters together made it possible for Python to understand that we wanted to print the line hello future Python programmer. But how was it able to do that? The word print here is a function name. A function is part of our code that we can use in order to cause some effect or evaluate a value. In this case, we use the print function to print the line hello future Python programmer to the terminal. Some functions come from Python itself. In this case, we never told Python that it should print something to the console when we used the print function. It already knew this, since it's a built-in function. Functions can also come from one or more of Python's modules. Some modules come with Python, and others require some installation. How modules can be installed will be covered later. Lastly, we can also write our own functions in our programs to make our code simpler, clearer, and just more elegant. Let's take a look again at the anatomy of the function that we just saw. Now that we know what the word print is for, what about the other values? This is another component of functions, namely arguments. We can pass arguments to a function by placing them between parentheses. In this case, we passed the line hello future Python programmer as an argument to the print function. The line is delimited with quotes, and a value between quotes is called a string. The quotes cut out a part of the code and assign a different meaning to it. The quotes tell Python that the text between them is not code and shouldn't get executed. Python should just take it as it is. If we passed another string to the print function, Python will print that string instead. Now, let's see what steps Python takes in order to execute a function. First, Python checks if the name of the function is legal. If it's a built-in function, it browses the internals in order to find an existing function with that name. If that fails, the execution is aborted. Then, Python checks if the function's requirements for the number of arguments allows you to invoke the function in the way that you just did. When the arguments have been validated, Python leaves your code for a moment and jumps into the code of the function that you want to invoke. In this case, the internal print function gets executed and uses the value that we passed as an argument to the function, the string hello future Python programmer. The function is executed and, in this case, prints the line that we passed to it as an argument. Finally, Python returns back to your code and it resumes the execution of the code block. Since the print function is an extremely important function when working with Python, let's look at all the possibilities that this function provides. If we want to print multiple lines at once, we can do so by invoking multiple print functions, each on their own line. An important thing to keep in mind is that there cannot be more than one instruction on a line in Python. If you want to print a longer sentence that should be separated with new lines, you can do so with a new line character. The N stands for new line, and the backslash lets Python know that the next character after the backslash has a special meaning. This prints the sentence with a new line. So far, we've only passed one argument to the print function. But what happens if we pass multiple arguments instead, each separated by commas? Python prints the exact same line as it did when we just passed it as one string. When we pass multiple arguments to the print function, Python combines the arguments together and prints them all on one line. In order to get a little more control over the output, Python allows you to pass special arguments to the print function, namely keyword arguments. One keyword argument is the end argument. The keyword argument end determines the characters that the print function sends to the output once it reaches the end of its positional arguments. Previously, we saw that invoking the print function on two lines meant that their output was also printed on two lines. This happens since the new line character is the default value that Python adds once it reaches the end of its positional arguments. With this end keyword that consists of just an empty string, we told Python to use an empty string instead of a new line. This means that both lines were printed on the same line. You can pass whatever value you want to use at the end of the hello output. Another keyword argument is sep. This keyword allows you to control how Python separates the outputted arguments, which is just a space by default. Combining the sep and end keyword arguments gives you full control over the print function's output. In this case, we're separating the arguments in the first line by an exclamation mark and a space. We're ending the output with a heart emoji and a new line. The second line is separated by a comma and a space, and ended with a smiley emoji. So let's summarize everything that we just learned about the print function. Print is a built-in function that allows you to print values to the console. Since it's a built-in function, we always have access to the function without having to import it or specify it anywhere. And since it's a function, we can call it by invoking it with parentheses. In between these parentheses, we can pass the values that we want the print function to output to the console. We also learned that the backslash is a special character in Python that we can use in order to tell Python that the next character is a special character. We saw this with the new line character that is specified by a backslash followed by an N for new line. Then we saw that we had full control over the output with the keyword arguments such as sep and end. Python has 7 types of arithmetic operators. The exponentiation operator receives a base and an exponent. You may be used to using superscripts when working with exponents, but in Python, we use these double asterisks instead of superscripts. We can now calculate the results for all the expressions. You may notice something special going on with the decimals. It's important to remember that if both values are integers, the result will also be an integer. However, if at least one of the values is a floating point number, the result will be a floating point number as well. You can use these single asterisks in order to perform multiplications. The floating point versus integer rule that we previously saw applies here as well. So if at least one of the operands is a floating point number, the result will be a floating point as well. With the division operator, we can divide values. However, you may notice something different here. Whereas previously, the operators returned an integer if both operands were integers, the division operator always returns a float. Python always returning a float when dividing values may not always be the behavior that you want. Luckily, Python also allows us to use the floor division operator, or the integer divisional operator, in order to return an integer as long as both operands were integers as well. Besides returning an integer, the floor division operator also rounds the values towards the lesser integer value. For example, 6 divided by 4 with the normal division operator is 1.5. But with the floor division, it rounds it down to the lesser integer value that it's close to, which is 1. When we divide 6 by -4, the result with the normal division operator is -1.5. However, when we divide them with the floor integer, the result will be rounded down to the lesser integer, which is -2. With the modulo operator, we can calculate the remainder after division. We can calculate the remainder after dividing 4 by 2 with the modulo operator. Since 4 can be divided into pieces of 2, there is no remainder after the division. So 4 modulo 2 returns 0. Now let's try to find the remainder after dividing 5 by 2. After 5 pieces have been split into groups of 2, there is 1 piece that remains. This is the remainder after dividing 5 by 2. So 5 modulo 2 returns 1. We can use the plus sign in order to add values, and the minus operator in order to subtract values. So far, we've only worked with binary operators. A binary operator expects 2 arguments, one on the left and one on the right. However, the minus operator is also a unary operator. We can use the minus operator in order to specify that the value should be negative, such as -2. For example, -6 minus 6 is -12, or 10 minus -6 is 16. So far, we've only used one operator in the expressions. However, we can of course use as many as we'd like. There's just one important thing to keep in mind: their priority. The unary operands have the highest priority. Then we calculate the exponential expressions, followed by multiplication, division, floor division, and the modulo. And last but not least, all the additions and subtractions are calculated. Let's take a look again at this example. There are no unary operators at the moment, so the next most prioritized operand is the exponential operator, which we're using here to calculate 6 to the power of 2. And 6 to the power of 2 is 36. Then the most important operands are the division and the multiplication operators, which we're using here. In this case, if the two operators have the same priority, we calculate it from the left-hand side. So first we calculate 36 divided by 9, which is 4. Then we calculate 4 times 10, which is 40. Finally, we only have the least prioritized operators left, namely the plus and the minus operator. Again, we calculate the result from the left-hand side. 10 minus 40 is minus 30. Minus 30 plus 1 is minus 29. This is why the result is minus 29. With sub-expressions, which are expressions between parentheses, we can change the default hierarchy a bit. Sub-expressions are always calculated first. In this case, the sub-expression 2 plus 3 results in 5, after which the result of that sub-expression is multiplied by 2. And 2 multiplied by 5 results in 10. Even though the operator within the sub-expression had a lower priority than the multiplication operator, Python calculated the result of the sub-expression first, since sub-expressions have a higher priority than the multiplication operator. So far, we've worked with some arithmetic operations that didn't really make sense. In this case, the 2 doesn't really represent anything, nor does the 5. Now, let's say that the 2 stands for the amount of apples that we want to buy, and 5 is the amount that they cost. Instead of just using 2 and 5, we can make use of something called variables. Let's create a variable called amount of apples and assign it to the value of 2. Then let's also create a variable called cost of apple and assign it to the amount that an apple costs, namely 5. Now let's try to use the print function again, but using the variable names this time, instead of just the direct numbers. Python prints the exact same numbers as we saw before, namely 10. You can see a variable kind of as a bucket to store a value. A variable has a name, such as amount of apples and cost of apple, and a value, such as the numbers 2 and 5. If you want to give a name to a variable, you must follow some pretty strict rules. A variable name can be composed of uppercase and lowercase letters, digits, and an underscore. The name of a variable must begin with a letter or an underscore. Upper and lowercase letters are treated as different variables, So this means that the lowercase cost of apple is not the same variable as the uppercase cost of apple. They can both have entirely different values and can be used in totally different contexts. And lastly, the name of the variable cannot be any of Python's reserved words. The meaning of a reserved keyword is predefined and cannot be changed in any way. If you want to use a variable name that should have the same name as a reserved keyword, you can do so by, for example, changing the casing. It can happen that over time, the value of a variable should change. Let's say that the price of an apple increased by $2. This means that the new cost of an apple is the original cost of an apple plus 2. We can reassign the cost of apple variable to be the original value of the cost of apple plus 2. When we print the sum again of the total amount of apples times the cost of an apple, it now correctly prints 14, since 2 times 7 is 14. We just incremented the value of the cost of apple variable by setting the value of cost of apple equal to the current value of cost of apple plus 2. There is actually a shorter way of writing this. So-called shortcut operators allow us to reassign the value of a variable based on the current value. In this case, the shortcut operator plus equals tells Python that we want to set the value of the cost of apple equal to the current value plus 2. When we print the sum again of the total amount of apples, it now correctly prints 14. The shortcut operator doesn't just work for the plus operator, it works for all the other operators as well that we've previously covered. So as you can see, the shortcut operator makes it easier to write shorter and cleaner code. Let's summarize the things that we've just learned about variables. With variables, we can store values. We give a variable a valid name, namely a name that starts with a letter and contains uppercase or lowercase letters, digits, or an underscore. The name of a variable cannot be the name of a reserved keyword. Python allows us to redeclare variables over time, just by assigning it a new value. This can also be done with a shortcut operator that makes it easier for you to write shorter and cleaner code. We write code that may not be extremely obvious to other developers on our team. In that case, we can write some comments in our code by writing a hash followed by the comment that we want to add. Whenever we actually run the code, this comment is emitted. Python doesn't do anything with them. Their sole purpose is to add some extra information for other developers on our team or just for yourself in the future. If your comment is pretty long and should be on multiple lines, make sure that you add a hash in front of all the lines. If you don't do that, Python will try to evaluate the code, which most often just ends up in a syntax error. Although adding comments is a nice way to make sure that everyone understands your code, definitely don't overdo it. It's always best to aim for self-documenting code. For example, writing a comment explaining what each variable represents is really not necessary here. We know that the amount of apples should represent the amount of apples, and the cost of apple variable represents the cost of an apple. You can also comment out code that you temporarily don't want to use. In this case, since we commented out the cost of apple variable, Python will not create a variable called cost of apple. So when we try to use it in our print function, Python will throw an error, since it doesn't know anything about a variable named cost of apple. Let's summarize what we just learned about comments. A comment is only useful for humans, and you can add them to your code in order to provide additional information that may be useful for other developers on your team or just for yourself in the future. However, wherever possible, try to write self-documenting code that doesn't need comments in the first place. We've seen that the print function allows us to print values to our console. Now, let's look at another useful function, namely the input function. The input function prompts the user to input some data from the console. It's able to read this data entered by the user and returns it to this running program. If you want to store the value that the user input, you can assign a variable to the input function. Let's say that we want to know our user's favorite color. The value of this variable will be whatever the user wrote as input. We can now use that value that the user submit in our program. The value of the input function is always a string. Even if the user inputs a number, this number is actually just a string. And this is important to remember if you want to do some arithmetic operations based on the value that the user input. Python throws an error here since we're trying to subtract 10 from a string, which is not a valid operation. If you want to make the string an actual number, you can use built-in functions in order to change the type of data. This is called typecasting. There are two types of functions that we can use there in order to typecast data. Int in order to turn the string into an integer, and float in order to turn the string into a floating point number. In this case, since age is an integer, we can wrap the value of the age variable in the int function in order to turn it into an integer before we subtract 10 from it. Since 22 minus 10 is a valid operation, Python doesn't return an error and just returns the result 12. You can also wrap the input in the int function directly. In that case, the value of age is always an integer. Let's summarize what we've learned about the input function. When using the input function, the program stops and the user gets prompted in order to submit a value. If you want to add a string in front of the user input, you can do so by passing the string to the input function. The result of the input function is always a string. With typecasting, however, you can change this to be a numeric type. And a program that doesn't use any inputs is called a def program. In Python, we can use 6 comparison operators in order to compare values. The equal operator checks if both values are equal to each other. For example, 2 equals 2, but 2 doesn't equal 4. The string hello is equal to the string hello, but it's not equal to the string goodbye. Next is the not equal operator, which does the exact opposite of the equal operator. Since 2 is not equal to 2, it returns false. But since 2 is not equal to 4, it returns true. Then there's the greater than operator, which checks if the left-hand apparent is greater than the right-hand apparent. The greater than or equal to operator is almost identical to the greater than operator. However, this operator also returns true if both values are equal to each other. The smaller than operator returns true if the left-hand apparent is smaller than the right-hand apparent, and the smaller than or equal to operator also returns true if both values are equal to each other. Comparison operators are very useful when we want to run code based on a certain condition.